Alright, so today we are going to be treating atomic theory. So you find out that one of the most important topics every year one student or every academic student does in the university, the first topic is always atomic theory. And what is atomic theory? Atomic theory dates back to the ancient Greeks during the times of Plato, Socrates, Aristotle, and so on. So they have this traditional philosophy called atomism. The belief was that everything that exists, or you call it every matter, that there is an uncut part. There is a part where if you keep cutting it, that there is a section where you get to, you can no longer go on. And that word atomos simply means uncut. So we say that atomic theory is a scientific theory that believes that there is an elemental, indivisible unit of matter called atom. Alright. So we move on from there to the 5 major atomic theories. You notice that atomic theory is something that happened from the 1800s. It had so much effect from the 1800s. So we move to the 5 major atomic theories. Number 1 is John Dalton's theory, and this video, the part 1, that is atomic theory part 1, which is this one we are starting first with it, is going to be on John Dalton's atomic theory. Part 2 will be on J.J. Thomson's atomic theory. Then part 3 will be on Niels Bohr's atomic theory. Part 4 will be on Lord Rutherford's atomic theory. Then part 5 will be on Schrödinger and de Broglie's atomic theory, wave mechanical and quantum number. Alright, so welcome. Welcome once again. My name is Engineer Okenwa, Shaw A Academy. And I believe if you're joining us for the first time, you'll find this channel very educative, because if you come to classes, you notice that when teachers give students the listing for atomic theory, especially when it has to do with John Dalton's atomic theory, they tend to just give it as notes, and students try to read it. Some of them cram it, and they don't actually place it that this is where this man's work revolved, or this is what this man work channeled his energy around. So in John Dalton's atomic theory, there are 6 key things that John Dalton focused on. The first thing he focused on was matter. The first thing John Dalton focused on was matter. Matter. The second thing he focused on, the second thing he focused on was atoms. Now the third thing John Dalton focused on was on chemical properties. That his theory, it centers around these listings that I'm giving you now, what I'm listing out for you. So next time you're asked to state John Dalton's atomic theory, you don't have to go and start pouring out your crammed notes. You just need to know that everything that you have there falls under this. It's actually on a subtopic. Then the fourth thing that his theory centered on was on chemical reaction. The fifth thing his theory focused on was on the law of mass conservation. So the sixth thing John Dalton's atomic theory focused on was on the law of fixed whole number ratio. So we are talking about atomic theory part 1, and this is what John Dalton's atomic theory actually focused on. John Dalton's atomic theory. So I said the first thing his theory focused on was on matter. The second was on atoms. The third, chemical properties. Fourth, chemical reaction. Fifth, law of mass conservation. Sixth, law of fixed whole number ratio. So how? Now talking about the how, he simply said that matter is made up of a small indivisible particle known as elements. And I told you in our last class that element is the same thing as atom, but it's just that atoms of the same kind is called element. Alright, so that's the first theory. He said that every matter is made up of small indivisible elemental particle called atom, or he says as an element. So from that, he leads us to atoms, the second part, the second topic that his theory focused on. So on atoms, he was trying to tell us that every atom, that atoms of the same elements, I told you that atoms of the same kind make an element. So he was trying to tell us that atoms of the same kind, that they are identical, while atoms of different kind, that they are not identical, they are unidentical. So what that means is that when you see a red object, for example, the minute your eye catches it, you know that yes, this is red in color. When you see something yellowish, the minute your eye catches it, you know that yeah, this is yellow in color. That is the same way. That is the same way that the minute you get carbon, carbon is the number 6th element in the periodic table. The minute you get carbon, yes, you know definitely, yeah, this is carbon because in the periodic table it has 6 in the position of 6, and that means that it has 6 electrons, 6 protons. But know it that during those times, John Dalton and the rest, they have not discovered protons, that is the subatomic particles, but they had this belief that when something is nitrogen, that everything that is nitrogen should act like nitrogen, that there should look like nitrogen, that there should be identical, that there should be something that anytime you place your hand on it, you can be able to say that this is nitrogen or this is oxygen. So atoms of the same elements are identical, while atoms of different elements are not identical. That means you cannot say that nitrogen is carbon because nitrogen is not carbon. Now the next thing he talked about was on chemical properties. And on chemical properties, he said that atoms of the same elements, that they have the same chemical properties, which is what, if you move down the line, that is in 1865, when Mendeleev, the Russian chemist, postulated the atomic laws, the periodic table. You notice that he made mention of atoms in the same group behaving alike. The same thing with Newlands, J.A.R. Newlands. He made the same thing, that is on the law of octaves. So if you notice, you see that his chemical properties behaving alike, it actually falls in J.A.R. Newland's octaves theory, where he said that every element after succession of 8 counts, that after succession of 7 counts, that the 8th element behaves like the first one. Yes, so that takes us to the 4th law, which is on chemical reaction. I hope I'm not too fast for your liking. You know, the idea or intensity is something that if you take your time to go through this video over and over, yes, then it starts to sink, it starts to become a part of you. All right, on chemical reaction, in the ancient days, it was said that sometimes, because of the way people are able to convert hydrogen and oxygen, mix them together, and you get water. And you know that naturally you cannot drink oxygen and you cannot drink hydrogen, but when you combine it together, you get water, a compound, something new. So it was said that in those olden days, that chemists started to think that they could use lead or materials to produce gold, because gold, you know, gold is valuable, yes. So they felt like they can do something and they can get gold. So they were trying to get a situation whereby they can mix atoms that are different to get a new chemical reaction. So what this law is actually saying is that you cannot get a different atom by combine. You cannot get, or should I say, you cannot get a whole new atom by using through chemical means. You cannot get a whole new atom through chemical means. Whatever you have there is definitely going to be in definite proportion to give you something that is obtainable. Just like when you mix H2 and O, it doesn't mean that if you mix H2 and O2 you will not get something. You will get hydrogen peroxide when you mix H2O2, that is, and you have in the ratio of H2 and O2, you get hydrogen peroxide. But when you mix H2 and 1 oxygen, you will get water. So what this law is trying to tell you is that in as much as now there are so many things you can do, should I say, to realize gold and the rest by changing the protons and the neutrons inside, but as at then he postulated this, saying that it's not possible, that you cannot get a whole new reaction or new chemical products by trying to mix atoms that does not have the same chemical properties with it. So that was it on this. And you know that in chemical reaction, what actually happens there is on the outermost parts, the outer shell of that particular element. Yes, so by then there was nothing like radioactivity, nuclear chemistry, isotopy and the rest. It has not been developed as at then. So this his theory was later worked on, but as at then he puts it to us that chemical reaction as a theory, that this is what happens, that you cannot do this, you cannot, in fact, that you cannot do magic, that whatever you put is what you get. That's what this is all about. Then the law of mass conservation. The law of mass conservation simply talks about where he stated that the mass of an element on the reactant part, that when you happen to combine it, that they do so in equal proportion. That is, that for example, when you burn firewood and that firewood happens to turn to ash, and in doing so it changes to carbon dioxide, carbon monoxide, that when you happen to in an organized way and carefully pull back your products, that you will see that the mass that you burnt is the same thing with the product, what you have after you must have burnt it. So that's what this law of mass conservation is talking about. Then the sixth one, which is law of fixed whole number ratio, he stated that when atoms combine, that they do so in fixed whole number ratio. What this means is that you cannot bring carbon and say you want to cut carbon into two so that you can get something half of carbon, then you use it to make a chemical reaction. It's not possible. So anytime you want to combine or you want to obtain anything chemically from a particular element, it has to be it has to be whole. It has to be untampered with, because the minute you tamper with it, or you say you are cutting it into two, or you are trying to go down on an element, it is no longer that element. When you take out 1 from 6, carbon is number 6 in the periodic table. When you say you want to work with carbon, but you gotta remove 1 from carbon, which is not possible. I'm just trying to show you a common sense example. You remove 1 from carbon and you say you want to work with it, it's no longer carbon. So you see that you've turned it to boron. Yes. So that gets us to the part where you know that for you to work with an element, it has to be that element. It has to be an element that is in its definite size, its definite atomic number, its definite proportion. That is the only way it can combine to give you a new compound. So I thank you for your time. Our next class will be treating J.J. Thomson. So I need you to watch, I'm gonna need you to watch this video over and over again.